the vacuum cleaner. It removes dust and dirt with every sweep. How does this machine generate storm force suction in a pod that's light enough to haul around the house? 85 parts work in unison to generate maximum suction. A bag that lets in the air, but locks away the dust. A steel propeller that spins faster than a power drill to suck in 500 gallons of air a minute. A super efficient motor that uses less than half the power of a hairdryer. It's a dust-hungry beast that's designed to last. Together, these components create the vacuum's ferocious appetite. The body must be airtight for good suction, but also accessible to throw sucked-up dust away. The secret to the cleaner's super suction is the factory's ingenious injection mold that squeezes the body into shape.
These are little tiny plastic beads. When I first came here, I thought they were like tiny little white marbles.
Ian's job is to make sure that each mold squeezes together exactly the right proportion of plastic beads.
It's all done on vacuum. You can hear it kicking in now. One of the machines is cooling.
If Ian gets the numbers right, the cleaners should be perfect. Get them wrong, and hundreds will be destined for the trash can. A vacuum cleaner needs an airtight drum to suck up dust. The secret is to make a plastic mold with a leak-free seal. So Ian uses injection molding machines to create an airtight body with ferocious suction. Sensors call in the correct volume of beads, which the mold melts and squeezes together.
So they get fed in, and then when they get the injection unit, then they're turned into molten plastic under high temperatures, about 180 to 220 degrees, around that area.
Two molds form the drum unit, a base that holds the dust bag, and a lid that holds the motor. A rubber seal makes sure that the joined-up unit is leak-free. The perfectly sealed body gives maximum suction. But what stops the motor from overheating inside it? This machine has a clever design to keep cool. The 620-watt electric motor sits on top of the suction fan. As the fan blades spin, they push air up towards the motor, keeping it cool even on full blast. At the other end, the airflow pulls in the dust, and a bag with tiny pores traps it safely inside. That's how this machine can clean your house without ever getting hot under the hood. For a vacuum cleaner, keeping cool is second nature, but the dust it devours could easily put it out of action. So the workers who build them must make sure that dust and motor never meet. They fit a bag and filter that catch the bulk of the dirt. Then, they fit the motor into a dust-proof casing.
If there's not a good seal, the suction would be no good for vacuuming anything up at all.
Kevin checks the motor of every cleaner that leaves the line.
Just want to make sure the seal's nice and tight between the drum and the lid.
This cleaner sucks fine. The motor generates a constant 100-mile-an-hour stream of air that sucks dust up from hard floors. But on a thick pile carpet, even these hurricane-force winds won't do the job. So how does the cleaner suck up dust that's ground deep into a woolen pile? Hidden inside the brush head, this machine has a secret weapon. A small turbine whirling in the airflow. A rubber drive belt connects it to a spiral brush, whose bristles kick up even stubborn dust. This turbo brush head spins 5,000 times a minute to give maximum cleaning power. This little machine can deal with a talcum powder Armageddon. Before each new model hits the showroom, it must get through the Vacuum Olympics.
We're in the dust pickup lab that's air-controlled in temperature and humidity.
Chris is the man who sets the gold standard. He spins the cleaners by their cables and stretches their hoses in this $700,000 vacuum testing facility. The next challenge is to suck up as much dust as possible from this test carpet.
We put down some Norman sand, which is some very expensive dust, which is required for everyone who's doing dust pickup tests to have.
This standardized dust allows Chris to check how good the cleaner is. To meet the required standards, the cleaner must suck up enough dust from the carpet.
So now we're stopped, we're just going to weigh the bag to see how much dust he's picked up. And that's 63.09.
This cleaner makes the grade. It's good enough to keep even the thickest carpets pristine. Millions of vacuum cleaners are sold globally each year. They eat up millions of tons of dust and make living rooms the world over just that little bit nicer.